We're gonna go over passing knots, but not through our system devices that are anchors, directional anchors. So how to pass knots through directional anchors, both when we're lowering out and then hauling up. And we could do directional anchors that are kind of on the ground, just like flat directional anchors, natural high directional anchors, and then we have our artificial high directional anchors. We're gonna go over how to pass them through artificial high directional anchors because it's a little more kind of touch and go, and you have to be cognizant of your resultant force vectors when you're doing artificial high directional anchors. So here we have just a basic gym pole that we quad guide out, and our 70-pound weight is our simulated load. And so right here we have two ropes that have been joined together with a butterfly knot, and we're lowering out. So we're passing a knot through a lower, and so we stop anywhere between like max a foot, 6 inches to a foot. Here it's about 3 inches. That's fine because I know what device I'm going to use to actually transfer tension. So a couple ways to do this. If this was a natural high directional or just a directional on the ground, like a natural directional on the ground, like steel I-beam or a concrete pillar, I wouldn't be so concerned about like where I put a system to transfer my load. With a artificial high directional like a gym pole, I don't want to clip anything to the head of this and then capture the load here, because that drastically changes my resultant force vectors, and that's kind of one of the things we want to avoid all along when we're building artificial high directionals, because we want to build something that's going to maintain our resultant force vector that's bisecting this pulley. And so that means that we are going to kind of mirror what we already have going on here through another pulley, and we're going to attach a line to the tension line of where our load's connected to. A lot of different things I can do, but if you look at how far I have to go, it's not really feasible to put an Aztec and drop it through that directional, that pulley. Plus, the Aztec has 4, maybe 5 lines depending on how you orient it, and we just aren't going to fit that Aztec through that pulley. But what I'm going to do is I'm going to take the back end of my rope, of this rope, I'm going to take the back end of it, the terminal end, and temporarily repurpose this just for a line tensioning system. So I'll take my back end, I need a rope grab, and I'm bringing it all the way up. Clip this in, and since we're lowering out, I want to try to keep everything close and uptight because we're going down this way. So if I can keep everything within relative close proximity. Okay, so let's go all the way back. Okay. Here we have options. If we didn't have an Aztec or a pre-rigged mechanical advantage system, I would use this anchor plate. I would take this, maybe put it through another device or a prusik, a rope grab and a pulley, and just maybe make some sort of lowering device, or even a munter might work depending on the weight of the load. But we don't really need to do that here if we have an Aztec. So I'm just gonna let this stay put. I don't even have to put this into any system. I'll just clip this in temporarily just so it's there. But really what I want to use is, if I have it, I'm just going to use the Aztec, because I can do limited lowers on this by clipping into the anchor, and I don't really have to extend this out too far since we're lowering. I just need to be able to capture initially what we've got, take all the stretch out, because I only have 3 inches before that knot hits that pulley up there, so I don't have much distance to do the actual full tension transfer, so I want to make sure everything is taut before I start. I've got a limited throw in my Aztec. I can haul up just a little bit to get even more tension off, let that Aztec prusik engage, and or, either or, doesn't really matter, and I'm going to lower out on my descent control device that's holding my main line just a little bit. As I lower out, I'm going to continue to lower out until this goes completely loose. So this is all slack now, and everything is being held on my system. This is now completely loose, so I can actually take this out, and this is why I wanted some distance, a few inches on the back side, to make sure that I could actually get this knot out, pass it, and now I've passed the knot. Can you see that? Okay, so the knot's been passed from this side to this side. Meanwhile, I have my secondary system holding the tension. We did the line transfer, and now I'm gonna transfer back onto this and then resume. I wanna take as much slack through my descent control device, in this case the Maestro, as I can. Take as much of that in, lock that off, get ready for high friction mode on my Maestro, and then I release on my Aztec and let that transfer over. And when we do that, this goes completely slack, and then I can get rid of my device or my rope grab. So my secondary system has completed its job. I no longer need it, and everything is back to where it was on my system. My knot's been passed, and I don't need the back side of my rope anymore, so this can go away. And then I need to make sure that I take out my secondary system up there before I continue on, but now I'm ready for a lower again. And that's how you knot pass through an artificial high directional on a lower. Now let's do the reverse on a raise. Okay, so on the raise, just the inverse. So here's my knot. I have to get this knot up through this pulley and on this side. So let's think about how much distance that's going to require. I mean, minimum a foot, maybe 2 feet to be on the safe side. So that implies a couple of things. I want to make sure that my rope grab plus the secondary system on the backside that I built right here, if you want to zoom down here, take a look at this. I need this as well as everything here to include this knot. I need ample space here so that I can guarantee enough travel rooms that neither line will hit anything up here. So maybe like 3 feet is probably more than enough if I know I'm going to go maybe a foot of knot clearance from this point all the way through. So that's just a general rule of thumb. The second general rule of thumb is how far do I want to extend that secondary haul system out. In this case, the Aztec, if I'm going to go maybe 3 feet, well, if I'm doing a 5-to-1 mechanical advantage on a simple system via Aztec, I should probably just extend the Aztec out as far as it'll go. It's going to guarantee that I have enough that'll actually continuously pull in one shot. So let's go take a look at it. So my secondary line transferring system here via rope grab, this is dead. It's just connected to the rope that's going through my main system, but it's not really anchored to anything else. Let's haul on this to transfer the tension. Right here, this gives us plenty of space to transfer this knot to the other side. We're gonna go through, pop this out. That's why you need a couple inches, because this will go taut and it'll suck that knot up into the pulley, which is why you want to give yourself a few inches to make it easier for you to actually pass this. Okay, and now we've passed it. We're still on our secondary system. We just have to do the line transfer over again. So let's go back. First step is to focus on my main system, take all that slack out, okay, and get all that tension out as much as I can, hand taut. And now I can revisit the Aztec here and then complete the transfer by lowering out on the Aztec and letting it go. When I do that, I can get rid of that secondary system altogether. And then whatever I had here, if I had mechanical advantage here, I'll resume whatever mechanical advantage I had. If it's a 3-to-1, I'll resume that. And then let's take a look at our line. So we're able to get our knot well past our directional. This can go away now, we don't need it anymore. And then you can imagine if this load was down a cliff somewhere, like, yeah, we've successfully passed our knot and we're ready to go. So that's how you do knot passes. Lowers and raises through an artificial high directional or any directional. We just don't want to put any device directly on the frame. We're converting it to an anchor frame when we do that, and we're changing the resultant force on our high directionals, and we want to avoid doing that.